or down by a slight amount. When the barrel moves up or down by a slight amount, the relative position of the plunger and the spill ports changes. Either it goes up or this position comes down. When the relative position of the spill ports with relation to the plunger goes up, okay, when the barrel moves up, fuel injection timing is advanced or delayed?
Advanced.
How is it advanced? It is delayed. And barrel moves down. Just try to visualize. Barrel moves down.
Barrel moves down, it will advance.
It will advance because it will cover the ports earlier. Okay, the fuel injection timing will be advanced or delayed depending on whether the barrel moves up or down. When the barrel moves up, your suction and spill ports are covered by the plunger later, microseconds later, milliseconds later, but it is going to cover it later. And when the barrel moves down, the spill and the suction ports, they are covered earlier. So barrel can only move up and down. Barrel cannot turn. The sleeve at the bottom can turn. The sleeve engages with the VIT rack. There is a VIT rack at the bottom. This VIT rack engages with the sleeve, and a part of the threaded part of the barrel is engaging with that sleeve, and the barrel will move up or down by a slight amount, causing the fuel injection timing, if it is moving up, to be delayed, moving down to be advanced. The VIT, which I told you, I think I discussed the VIT diagram with you, yes or no? 40%, 85%?
Yes, sir.
Yes,
So,
sir.
40 to 85%, what will happen? Advancement or delaying will happen? Tell me. Yes, it is advancing, which is taking place from 40% of the load to 85% of the load. And from 85% of the load to 100% of the load, what is taking place? Is it constant?
It retards slightly. Sir, retards slightly.
Yeah, it is retarded slightly. So as to keep the Pmax constant from 85 to 100% of the load, right? So now you have understood that how it is taking place, how this thing takes place, that I have explained to you. Yes, diagram is a little bit complicated. You have to understand the working of suction valve and puncture valve. And with a simplified diagram, you can explain that there's a suction valve over here. Now I think I'll zoom in further and I'll explain to you how this suction valve is working. Okay. You can see in between there is a gray colored spring which is there. There is a spring. This is the spring which is keeping the suction valve normally closed. Which one is the suction valve? This red object which you see. This one. This is the actual suction valve. ये wall part है इसका. The entire thing is known as the suction valve assembly. ये है wall portion which will okay, this is seated over here. This is contacts which are there, or two line contacts which are there. So valve is seated. So valve sits over here, and over here. And it doesn't allow any fuel to leak in or leak out, come in or come out. Nothing can take place when the valve is closed. No passage of the fuel can take place. Now, when the plunger is moving down, there is a low pressure which is created inside. You have a low pressure created inside. This low pressure will be acting on this differential area. You have an area over here and you have an area over here. You have an area, okay, you have this differential area which is there. So you have the, if I take a projection of this area, this entire area will be something like this. If I take a projection of this entire area on which fuel pressure is acting, so it is a negative pressure which is acting. Negative pressure means vacuum. which means it's trying to pull the plunger up. It's trying to pull the suction valve up. Because vacuum create ho raha hai, so it is a negative pressure. So it's trying to pull the suction valve upward. While here in this projected area, ये जो छोटा सा projected area है, in this small projected area which is there, you have the 8 to 10 bar fuel pressure acting and trying to push the suction valve up. So considering both the pressures, the inlet side pressure of 8 to 10 bar minus pressure inside the barrel.
Excuse me, sir.
Yes.
Sir, your voice is not continuous, sir. It's lagging or it's getting stuck in between.
Okay. So I can't help it much. If you are able to hear me clearly, then I can only. So what all you didn't get, I'll repeat that. If you can tell me.
Sir, means you were telling about the fuel pressure near to 8 to 10 bar, something like that, and after that it's getting stuck your voice.
ठीक है. So I'll repeat again. See, if you see this very clearly, you have some area, projected area. इसका जो भी यहाँ पे surface है ना, if I take a projection of this suction valve, you have a projected area. ये projected area पे you have the pressure which is prevailing inside. यहाँ पे जो plunger के ऊपर में pressure है, this pressure is the negative pressure when the plunger is moving down. So this pressure is acting on this projected area. And since it is a negative pressure, it is acting upward. While on this suction valve, on the outside, you have this much area, small area, and on which 8 to 10 bar of suction pressure is acting, right? So you have a small area down below, and on this you have the suction pressure, 8 to 10 bar inlet side pressure is acting. On the top, you have a bigger area. This bigger area is also subjected to a pressure, but that is a negative pressure, which is again upward. So both the forces, they will act in upward direction, F1 and F2. So the net force F1 plus F2 is acting in upward direction. And this is good enough to overcome the downward spring force, Fs. Spring is trying to keep this suction valve closed. So F1 plus F2 becomes greater than Fs, the spring force, and that causes the suction valve to open up. The suction valve opens up. Once the suction valve opens up, the fuel will start to flow in through this gap. Okay, yellow colored thing, what you see over here is the suction valve body. This is a suction valve body. It's the body of the suction valve into which this red colored suction valve has been fitted. A red colored suction valve is fitted in this yellow colored suction valve body. The fuel will flow in and it will fill up this entire space. Now the plunger reaches the bottom. Even when the engine is in shut-off condition, that time this fuel pressure 8 to 10 bar is good enough to lift the suction valve against the spring pressure and allow the fuel to flow in and allow the fuel to pass through the fuel pump body through the high pressure pipe into the fuel injector and recirculate the fuel oil. Is that clear? Is this part clear to all?
Yes, sir.
Okay. Now, when the plunger starts to move upward, the moment the plunger starts to move upward and the top of the plunger covers the spill port. Top of the plunger has just covered the spill port. So your fuel delivery will begin. So your fuel is pressurized. The moment this moment is happening, the moment this event or this instance is taking place, this event is taking place, there's a high pressure which is generated over here, which immediately acts on this projected area and shuts down the suction valve. Because it's a very high pressure, it closes the suction valve immediately. And suction valve is firmly seated and the fuel high pressure continues to go through the high pressure pipe into the fuel injector and fuel delivery begins. So the moment the top of the plunger covers the spill and the suction ports, the suction valve is completely closed. Because of the pressure difference, it is completely closed and the fuel delivery will begin. Is that clear?
Yes, sir.
So I have explained to you the working of the suction valve also. Suction valve is this much. Itna part suction valve ka assembly hai. This is the suction valve assembly. Okay, this blue thing what you see on the top is an arrangement to retain the spring. You can call it as a spring retainer. So you press the spring in, gray colored is the spring. This red colored thing what you see is the valve, and yellow colored thing what you see is the suction valve body. Is that clear?
Yes, sir.
Clear, sir.
Okay. A puncture valve, I have already explained to you. So you can see the puncture valve. Green colored is the puncture valve on the top. Okay. And just bring it slightly down. Yeah, here. Or maybe I'll zoom out a bit. You can see the puncture valve is connected. इसमें high pressure pipe नहीं दिखाया है because this is a view 90 degree away. So यहाँ पे कहीं पे high pressure pipe होता है 90 degree away. So ये high pressure fuel goes through the high pressure pipe into the fuel injector. Okay, so that will be going in. Now you have this piston, that is the pneumatic piston on the top, and air connection will be there on the top. So this is the air supply, maximum up to 7 bar, which will be coming from the top. And this blue colored spring you have it over here. This pink colored object which you have is the spring retainer. It keeps the spring pressed in. And this green colored object is the puncture valve. This is the puncture valve. Okay, so this will be kept closed normally. And when you give the signal, that signal comes, air signal comes. That time this piston will move down. It will. You can see the piston can move down by only a small amount. It's only moving down by a small amount. And that is good enough to open the puncture valve. And the fuel oil leaks out through this opening. It will go through this line and it will go back to the suction side, the inlet side, the fuel oil supply side. Is that clear?
Yes, sir.